Thank you very much. I have to say I'm delighted to be back in the room. Last time I was involved with QUALICOAT presentation, we were in a TV studio in Woolwich. So it's great to be back back in the spaces. So the future of aluminium in facade construction. I'm both from Michael Stacey Architects and the Bartlett School of Architecture, University College London, and we're just on 22 Gordon Street, where our summer show will open on the 1st of July. The future of aluminium facade construction is bright. It's orange. No, actually it's copper coloured. And here we see Ely Museum, Cambridgeshire architect hat projects, copper coloured polyester powder coated aluminium. Interestingly, this aluminium won an RIBA award as part of a conservation project. In this country, we love our heritage and our built heritage, but that still means there's a role for aluminium. Interestingly, in the context of listed building, high quality design is essential. But this type of finish, which seems to be growing in your industry, is mimetic. It's part of the mimetic tradition of architecture that stretches all the way back to the ancient Egyptians. They made stone columns that looked like bundles of corn or papyrus, and that's where the form of their columns comes from. But I'm going to take you back to the future, to a future before Queen Elizabeth had been coronated. We're not going back to 1931, we're going back to 1953. So the current queen is about to be appointed, crowned, and here we see a wonderful sculpture, essentially of her mum and dad, by Henry Moore, cast in 1957. Now, Henry Moore said, "Truth to materials should not be a criterion for the value of our work. Otherwise, a snowman made by a child would have to be praised at the expense of Rodin or Borromini." The importance of that is truth to materials was a sort of touchstone of modern architecture. And it's interesting that in this post-war, post-Second World War period, Henry Moore, a radical sculptor, was pointing to a longer, perhaps arguably a stronger tradition. And in the hands of Bernini, stone becomes flesh. It's changed in front of our very eyes by his skill. Now, your industry seems to be able to produce panels that look like concrete, or in this case, terracotta. It's student accommodation at the University of Warwick. Architects this time are RH Partnership, and it wins an RIBA West Midlands Award in 2021. Now, I've calculated that this cassette system of aluminium is 27 times lighter than an equivalent precast concrete panel. But what we need as architects and engineers is a full life cycle assessment of the benefit of using aluminium. Because if my colleagues just use the sort of embodied carbon or embodied energy figures that are out in the world, they might not specify aluminium. So we need to learn the complete benefits of specifying aluminium. And oh, by the way, this is cracked clay polyester powder coating by Powder Tech. So credit where credit is due, and we've just skipped forward a bit. Aluminium is wonderful that it's part of a circular economy, and it's been part of a circular economy since the 1950s, more or less, as data began. And everybody has a part to play. Today, we're really here discussing finishes. I come in terms of architectural design, although I did work in the industry. And then there's the crucial phase of in-use. And there, the building owners and building management have a key sustainability responsibility in terms of stewardship. It's very hard to make maintenance fashionable, but it's crucial, and we'll come back to that. Now, I've spent my career using aluminium. I started off working on the Hong Kong and Shanghai Bank for Norman and Wendy Foster. And these are the recent books. The latest one was mentioned. And really, they look at the fundamental benefits of aluminium. And they're all downloadable, and I'm sure the link will be provided by QUALICOAT. I'm working on a new book, which is Aluminium, a Studio Design Guide, which has a chapter dedicated on finishes, because the world of finishes is almost a sort of complete world of its own. It's the point where our eye rests on a building, is the material that you provide. But one of the most important things in architecture is durability. In transportation, it's the lightness of aluminium, it's light weighting, but it's the long-lasting quality of coated aluminium that is important. I'd like to see the durability standards of Britain increased, and actually many clients don't realize we actually have durability standards for housing and for major buildings. And we estimate that the life expectancy of a well-coated aluminium product that is washed by the rain could be as much as 80 years. And we actually went out and we tested polyester powder coating from, in this case, it's Herman Miller by Grimshaw. Interestingly, Herman Miller have now left this building. This was coated in 1983, so it's way beyond its original guarantee period. And we found that although it had faded, we were doing non-destructive testing only, that the thickness was still 43 to 75 microns. It comes from an era when only gloss was available, so it's gone from 100% to 18.4, and there is a significant color variation. And you can, there's a peer-reviewed peer-reviewed paper that I did with Chris Bayliss, formerly of the International Aluminium Institute. But some 20 years ago, I wrote that the development of finishes for aluminium is an example of sustained R&D within the building industry. The guarantees offered on super durable polyester powder coating and anodizing represent some of the best product assurance within construction. And that is based on long-term testing and the sort of specifications that we've just heard about that are provided by QUALICOAT. Now, have we gone too far? It's much better to wash a building than repaint it. And it took me a very long time to take a photo of people actually washing their buildings. Interesting, this is nothing more glamorous than the Holiday Inn Nottingham, where the cricket supporters will have been staying, and they're watching the cricket now for free. I think I'd be there if, as a former professor of University of Nottingham, if I wasn't talking to you. Now, these are three examples of the sort of QUALICOAT guidance on cleaning intervals, of which you're probably very familiar. Architects and engineers do have to watch out for special circumstances, such as cladding a building that's on the air side of an airport, because you've got a very specific pollution. And the important thing in the future is that these cleaning cycles are used in the in-use phase of whole life cycle assessments. I have a very good one from Arup on Guy's Hospital, but actually they recommended cleaning it too often. It'll be very interesting to learn whether the National Health Service are doing that. Oh, hang on, I'm not so good with this clicker. So this is a look at a fairly recent building, formerly known as R7, and it's just north of us in the King's Cross development by Argent. The architects are Morris and Company. Now that's a relatively young man called Joe Morris, not William Morris, for those of you who know your arts and crafts architects. Now, this building is known as Pinky and Perky. Now, when I say this to my students, they look at me totally blankly. Some of you will remember that Pinky and Perky were two animated children's characters, a bit like Peppa Pig. Now, this probably shows you that our industry is growing old, that we're referencing. But it is two shades of pink. Now, I used to use pink cladding as a metaphor. I'd come to you and I'd say, I want a really nice shade of pink, say 40 years ago. And people would say, oh, we don't make that. And then 5 years later, someone of this industry would come back to me and say, Michael, we can make that color now. We've sorted it out. And maybe someone later can tell me how quickly you can do a new color. And the problem for the architect is we finished that nursery school 4 years ago. But here we see Morris & Co. using two shades of pink, and we go from beautifully, carefully crafted drawings to a Class 2 polyester powder coated aluminium assembly with the powder provided by Interpon Powder Coatings with a 40-year guarantee. Now I'm going to quote Mo. I hope I'm getting this right, and I think it fits with the slides we saw before. The specification of super durable polyester powder coating Class 2 has risen 10 times faster compared to Class 1 in the past 10 years. Now in terms of sustainability, people will be looking for those longer guarantees. They're taking the future seriously. And here we see the Shard. We've seen an image of this before, built by Renzo Piano Building Workshops, completed or designed by the architect Renzo Piano and his colleagues, completed in 2013. It has 73 floors above ground, and its curtain walling is coated with super durable polyester powder coating. On very tall buildings, I think a responsible architect needs to at least specify Class 2. Some of the tallest buildings in the world, we actually don't know how to demolish them. And of skyscrapers built in the last 100 years, over 150 meters, only 7 of them have ever been demolished. And 4 of those were sadly demolished because of 9/11. So this is a footbridge in Canada designed by the Maddie Group. It's actually an equestrian and pedestrian footbridge. But it's welded aluminium, so it's just left in mill finish. And here we see them using the same technique for an oil rig. I'm actually not allowed to say whose rig it is and where it is in the world, but it links to oil production platforms. Now, with funding from the Canadian government, Maddie Group developed what they called the Maker Bridge project. Using extrusions and castings, they're able to make the bridge from discrete components, which enables them to offer their clients finishes, be that polyester powder coating or anodizing. In 2016, they used this technique to make a rapidly deployable military bridge. And of course, it's for the Canadian Army, so it's polyester powder coated in dark olive green. And it's deployable by 8 squaddies in about an hour, and the sort of tragic scenes that we saw in the first phase of the war in Ukraine, you could see how this sort of bridge would actually have humanitarian purpose as well as military purpose. The original bridge was capable of taking small vehicles, but in 2020 they designed a new, longer, improved version of their deployable bridge, which is made of 4-meter modules and up to 24 meters long and capable of taking heavier vehicles. Now, the importance of this bridge is that it's an example of what I'd call design for disassembly, but I've learned that in BS 8887, we should now be describing this as design for manufacture, assembly, disassembly, and end of service life made. And that means that we can make components that can be interchanged, we can make buildings that can be relocated, we could reuse components from old buildings, we could return rain screen panels to be recoated at the end of their guarantee period. And if all of that doesn't work out, we can send it easily off to be recycled. Now, interestingly, there isn't yet a made BS 887 for the construction industry. And here we see the latest Maddie group, who are a design and build group in a rather sort of rather idyllic setting. So it's incredibly important that we collectively develop life cycle thinking for aluminium. And this is the title of a book in the Sustainable Cities series, authored by Stephanie Carlisle, Effrey Freelander, and Billy Fairclough, who at the time were all at Kieran Timberlake, the architects of the new American embassy here in London. And in this study, we compared the sustainability of thermally broken aluminium windows, all wood windows, aluminium clad windows, and PVCU windows using a functional unit of 1 square meter and Simmer Pro software. And again, this is a peer-reviewed paper. Now, I didn't altogether approve of this study in the sense that scenario 1 was little to no maintenance. The only scenario really we should be discussing with our clients is high maintenance, long life. But in the middle, we studied basic maintenance. Now, interestingly, my university is not very good at maintenance. And we were setting the building life cycle at 80 years. I'm getting the 2-minute warning. Now, I expected the aluminium-clad wooden window to be the best performing window. But interestingly, the best performing window is the all aluminium window. And we're happy for others to challenge that, but interestingly, they haven't. Now, polyester powder coating is inherently resourceful in the way it is applied. You have a very small loss. But I must say that energy is becoming the sort of almost the elephant in the room. And as energy is reduced, you get a lower embodied impacts at the same time. So I'd be very interested to hear if the low temperature curing powders becoming available. Now, interestingly, in the last 6 years, the embodied energy of primary aluminium in Europe has gone down by 12% to 140 megajoules. In the future, I think your specifiers will be asking for aluminium only from a single power mix. And the interesting thing here is aluminium produced using hydroelectricity actually has a negative global warming potential. It has a small use of fossil fuel, and in the Canadian industry, that's because they are 96% powered by hydroelectricity. Remembering smelting is a continuous process. We successfully specified this on an office building in Oxfordshire, sections from Canada, double glazing or triple glazing from England. Our only British smelter is a hydroelectric smelter at Loch Harbour, and therefore I argue that that should be the base case of the energy of Britain, and I'm getting cancelled. I think you already heard that recycled aluminium only requires 5% of the energy of primary. But the thing you need to be careful of, or we need to be careful of, in the world, there is currently only 34% recycled content. So unless you've got a closed loop recycling source, such as the one founded in Germany, a responsible specifier should only be asking for 34%. But I think this sort of circular economy, that's an old Heathrow building, will become part of the future. So at that point, with the end of service life of this particular building, I'm going to end my service life as your speaker. Thank you very much.
Thank you very much, Professor Michael Stacey.